Hello everyone, welcome to my U programming club. Today we will be solving another daily Leetcode challenge. And challenge name is minimum operations to reduce x to 0. So you are given an integer array nums and an integer x. In one operation, you can either remove the leftmost or the rightmost element from the array nums and subtract its value from x. Note that this modifies the array for future operations. Return the minimum number of operations you have to reduce you have to do to reduce x. So what you can do is what the problem statement is saying is array will be given to you, it's nums array, and integer x will be given to you. In one operation you can either delete left part of your array and subtract this left part. Either this operation can be done, and in or you can do this operation, you can remove the right part and subtract it from the x value. So either this operation can be done or this operation can be done. So you have to return what will be the minimum number of operations that will be required to reduce x to exactly 0 if it's possible, and otherwise if it's not possible, then you have to return -1. So let's have a look at the constraints of the problem. So the length of the array will be of order 10 raised to power 5. Nums array will be of order 10 raised to power 5. And the values in the nums array will be of order 10 raised to power 4. And the value of x will be of order 10 raised to power 9. So solve this particular problem. We'll be using binary search. Now you may ask that how do I know that a binary search will work here? For example, let's consider a brute force approach. In this brute force approach also you have to apply a little optimization. First of all, I would like to introduce a new concept for those of you who do not know, prefix sum. Those of you who are not familiar with this concept, prefix sum, I will be providing a link of an article describing this prefix sum. So what you will do is, let's take example of this particular array. Let's say this array is given to you. Let me quickly change the slide. Yeah, this array is given to you, and you have to generate a prefix sum array from this. What you will do is, as the name suggests, you will add the previous element to the current element. So this particular element is not having any previous element, so 1 will be the answer for this element. Now this element is having one previous element, which is one previous element in this prefix sum array. So previous sum was 1, so 1 will be added to 1, it will be 2. Now this particular element is also having one previous element, so previous sum was 2. 2 plus 4 will be 6, and this particular element is also having one previous element, so 2 plus 6 will be 8. Similarly, we will continue. 3 plus 8 will be 11. So this will be your prefix sum array. Here, if I mark the indices of this particular input sample array, 0, 1, 2, 3, and 4. So the formula for prefix sum, if your index is not equal to this, these are the values of index. Index is not equal to 0, then your prefix sum will be of a particular at a particular index will be nums of index plus prefix sum of previous sum index minus 1. So this will be the formula to generate the prefix sum. And you can check that article also, for which I will be providing a link for regarding prefix sum. So once you have this array, let's say you can delete how many number of elements, what will be the range of the elements that you can delete from right hand side. Let me quickly change the color. What will be number of element that you can delete from right hand side. It will be 0 to size of nums array. So you can run a loop from the last index to the very first index, and you can keep some variable. Let's copy the array, prefix array. Both of these array are required, so let's copy both of them. So you will run a loop from 4 to 0 index, and you will keep a variable suffix sum. It will be the sum of the elements that you will be deleting from the right hand side. This, let's say you delete 3 and 2, then your suffix sum will be 5. Let's say you delete only 3, so your suffix sum will be 3. Then let's say you delete 4 also, your suffix sum will be 9. Then let's say you delete 1, your suffix sum will be 10. Similarly, your suffix sum will be generated just like the prefix sum. But instead of storing it in array, we are just using a variable. Only difference is that. So now let's say I decide to put a partition here. This part you will delete from right hand side, right part, let's say, and the left part that you will delete will range from 0 to 2 second index. Left part range that you will be deleted, that can be deleted. So if you at all decide to delete the made some deletions on the left hand side, then this particular range will be of indices will be there which will make of your left part or left deletions. I hope till now you are able to understand. Now let's say how you will be deciding what index will be the most optimal index for current number of deletions in the right part. So you will run a loop from 0 to 2. So basically these will be 2 loops. One loop will be running from 0 to 4 or 4 to 0 in this particular direction. Let me quickly change the color. I think this color will be right. So to decide suffix values, to find suffix sum values, one loop will be learning from uh, right to left. And to decide the optimal prefix sum value, one loop inside this loop will be running from left to right. Uh, to account for this possible range of left part. So this partition can be placed anywhere in this particular array, and based upon the minimum value that we can find, uh, we will get a minimum number of operations. But this will require two nested loops, so time complexity will be order of n square, and your size of the nums array was given to be order of 10 raised to power 5. Let me cross check also. Yeah, it was 10 raised to power 5, and if you square it, it will be 10 raised to power 10 operations, order of 10 raised to power 10 operations. So these are greater than the limit of 10 raised to power 8 operations allowed in 1 second. Basically, if the number of operations of your program, number of ops of your solution exceeds or become equal to this limit of operations, then you may get a TLE. Otherwise, your solution will be accepted. So here you will definitely get a TLE, time limit exceeded, and your solution will not be accepted. So in order to optimize it, what we can do is, first of all, first loop will be to generate the prefix sum. You cannot change this suffix sum loop. Let's call this suffix sum loop. You need your right hand side number of deletions, so it cannot be optimized. But your this left hand side, let's say partition is made here, and left hand side range is this. To find your optimal range of left sum or left part in this particular nested loop, here optimizations can be made. Here binary search can be applied. What will binary search? We are searching for using binary search. The index. Let me quickly change the color. The index till which uh, the deletions from left hand side will be made. And it will run in of log n time, where this n is the size of the nums array, order of log n time. So your overall time complexity, this will run in order of n time. Overall time complexity of the solution will be order of n into log n, where n is the size of the nums array. So size was 10 raised to power 5 into 10 raised to power log of 10 raised to power 5. These maximum these number of operations will be required to solve this using your optimized solution. So let's see what log 10 raised to power 5 is. As you can see, it's very less as compared to 10 raised to power 5. It's basically 16. So 16 into 10 raised to power 5 is lesser than 10 raised to power 8 limit. So those of you who are not familiar with this concept of limit of number of operations, I will be providing a link of an article describing how the time complexity of accepted solution varies according to input size. And also, those of you who are not familiar with binary search also, I will be providing a link for binary search, article describing binary search. Three links will be provided. One will be for prefix sum. I will highly recommend you to know all these techniques before proceeding with the solution for the video. So your solution will be accepted. Let's have a look at the implementation. Let me quickly zoom out. I think it was particular font size. I don't know actually. I think it's fine now. So what we will do is, first of all, we will generate the prefix sum array. We will generate prefix sum array to find the sum of left and right hand side deletions individually in O of one time, order of one time. You will get the number deletion sums of right hand side and left hand side. So prefix sum is used for that. And then what you will do is, you will try to find the optimal value of number of right and left deletions in order to achieve sum of x. So this particular loop will help you to find, this loop will help you to find optimal right deletions and this in case let's say your target your remaining value of the target, it will be the remaining value of target which is x minus suffix sum or sum of right deletions. Let's say your target is 0, then you need not to check if target is 0, then you need not to check for left deletions, because you have formed the target by just deleting numbers from the right. So this binary search will help you to find the optimal number of left deletions. This binary search will help you to find optimal number of left deletions. At last, you will return your minimum operations. Or -1 in case you are not able to form a sum of x from any number of from left and right deletions. So this will be our approach and the solution. Code will be available in C++ and Java both. So thank you for watching. Thanks.